Hello, my name is Emma Seiler, and I did problem 1 for the oral test problem. So problem number 1 was looking at a ship trying to leave the Earth's atmosphere, and it said the required velocity to get off into the atmosphere, assuming it's going in a straight line, is 8,000 meters per second, and it has to reach that velocity in 8.5 minutes, or 510 seconds. The question was asking for the average velocity, technically. So I used the equation average acceleration. Average acceleration equals the change in velocity over the change in time. So that resulted in an equation looking like 8,000 over 510 seconds, and that equaled 15.69 meters per second squared. So what does this mean physically? The velocity that you needed to reach, you have to reach in 8.5 minutes. So the period of time and the displacement we're looking at is not from the ground to the point that it wants to reach, not to where it's over the atmosphere in space and floating. What it's looking for is how much acceleration you need to get to that velocity in the time period needed. So average acceleration equation that I used would fit. And it kind of makes sense to me in the sense that you want to reach an average velocity like here, and it's backwards. So I'm sorry, but I can't write backwards. This says 8,000 meters, that's 510 seconds, meters per second. You want to reach that point, and as in lecture, you see that if the velocity is increasing at a constant rate, then the acceleration, this is 15.69 meters per second over 510 seconds, is constant. You have to keep that constant amount so that you can get to this point. So the second part of this problem asked for the total displacement in this time, that time being the 8.5 minutes for the takeoff to get to the velocity needed to leave the Earth. So to use this, I used a kinematics equation. I used displacement equals initial velocity times time plus 1/2 of the acceleration times the time squared. So I used this because I knew the initial velocity, it was 0, and I knew the time, which was 510 seconds, and I now know the acceleration from the last part of the question, 15.69 meters per second squared. So I plugged it in. Of course, the initial velocity is 0, so it'll cancel out the initial velocity times time part of the equation. So it just becomes the displacement equals 1/2 the acceleration times time squared, or 1/2 15.96 meters per second squared times 510 seconds squared. This resulted in 2,040,000 meters. So in the 8.5 minutes it took to get to the velocity of 8,000 meters per second, the ship traveled 2,040,000 meters. This isn't too surprising because it is a spaceship and it's going very fast. And I would expect you want to go a couple million meters up into the air if you want to get out of the Earth's atmosphere. And I'm sorry, my cat's trying to jump in front of me right now. But that is the answer to the question. The part A of the question is again 15.69 meters per second squared, which I found using average acceleration problem, and the displacement was solved using kinematics, and I got 2,040,000 meters. Thank you.